Hi, this is Mr. Pearsons, and I'll be going over first part of 4.1a that Mr. Stewart gave on notes previously. And so I'm just going to go right in. In general, I will show it by these 4 different steps there. Sometimes a step might be skipped. Whatever the case, let's go ahead and take a look at the first one. And the first one, I want to identify my parent function, and the parent function is just that basic function that's associated with it. Technically, there's a vertical shrink there, but really it's just the slope that we're looking at. And then the next part of it is recognizing there will be a reflection of the x-axis, and I will just write it like this, showing there's a negative like we have on that second step up there. The third step is the vertex, and the vertex is also like the y-intercept there, and I'll put it in 0, 4, and then there is no reflection in the y-axis. So this is really just a slope-intercept problem, so really don't have to go through all those details on there. But if we start off at 4, and there is our slope, and we're going 1 down, 2 over, then our final graph will look something like this. All right, so let's move on to another problem. And I'm going to make this one a little bit larger because there's a little more to do with it. And of course, you can pause at any time if you're not sure about a part. But let's go ahead first and determine the parent function on our first step here. And the parent function is just y is equal to x squared. And that graph will look something like that. The second step, at least the way we have it set up here, is there is that negative on the outside there. So that tells me there's going to be a reflection in the x-axis. So I just write it like that as a reminder. And my next step is giving the vertex. Now the vertex, that inside number there, the -3, we always change the sign of that. And so that's actually become a 3. And then that last number there, the -2, that's going to be the the y part of that vertex. So we have 3, -2. And the last step, there's going to be a reflection in the y-axis. Oh, so by the way, this is going to be going down there. And a reflection of the y-axis, so I'm just going to write it this way to remind us what it's going to look like. And so let's go back to our original part up here. I'll start with where we already have it reflected. And my vertex right there is going to be at 3, -2. Now that's not my final graph, but it's going to be doing something like that. And then that's going to reflect on the y-axis. So this is 3 units over. And so my final graph will look something like this here. All right, and then you might write what that final ending vertex is going to be, and that's going to be at -3, -2. All right, so that's what that one looks like. All right, going on to J, that last problem on the page there, which will be a little more involved because I have that 2 on the inside there. And we need to factor that out because we want to get it looking like what we have up here with no coefficient on that x. So what I need to do first, before I go through all my steps, is write this out. And what I'm going to do is factor that 2 out, but I got to keep that in the parentheses. I'll factor the 2 out. I'll get -x, and I'm going to divide those both by 2. So that'll give me a +2 there, squared, -3. So I'm trying to factor that 2 out, and in doing so, we notice that 2 is going to be squared. So when I write my new equation out, I'm going to have 4, that's going to be negative x plus 2 squared minus 3. Okay, we got to have room to put the graph on there. All right, let's put all our steps in then. Our parent function, of course, is just y is equal to x squared. This time we have a vertical stretch of 4. So I'm just going to kind of put that in a box over there. And my graph is looking like that. Next step, reflection in the x-axis. There's no negative in front of that 4 there. Look at that 4. That's just positive. So there is none. So I'm just going to put a slash through that. And sometimes that step is even skipped if you look at the answer key. The vertex again, I take the opposite of that negative 2 of that 2 right there to make negative 2. And my last step, because there's a negative with that x there, we are going to be reflecting in the y-axis. So I'll just, as a reminder, I put that like that. My eventual vertex, the x is going to change sign, so it'll look like that. All right, so in graphing this, I have my original function there, it's an x squared, and I'm going to put it over here at negative 2, 3. And it's going to be going up. And this is not the final answer, but it just gives me an idea of, before I actually do the reflection of the y-axis, which is that 4th step there, what it's going to look like. And so this graph right here is going to reflect, I need that. It's 2 away from the y-axis, it's reflecting over, and it'll go right here. And the last little step of that actually is it's a vertical stretch of 4. So it's actually for 1 over, it's going to go 4 up. Or perhaps you just show it this way. If I picked one point, say 1, and I plugged it back into that original function up there, I would get 1. And so the other point we're working with is right there. And my graph will look something like that. And again, yeah, the final vertex. Okay. So on the backside then, we're just going to look at 2 problems there. We don't have to graph on these ones. All we need to do is put it in standard form. And by standard form, it means we're factoring out that. For example, in this case, we're factoring out that 4. And then we're putting the steps down. So let's go back to here. And again, the first thing we want to do is within the parentheses, I'm going to take that 4 and factor out from those 2. I'm basically dividing those both by 4. And that'll leave me with 4 times x minus 2. That whole thing is squared plus 9. And maybe you do that in one step, but it's nice to see that process going from there. So I'm pulling the 4 squared out. Let's write that again like this, 4 squared. And that's going to give me 16. So that's 16. Whole thing comes out, and then I have x minus 2 squared plus 9. And that's going to be f of x. All right, so my steps now. My parent function, again, is x squared. So I'll write y is equal to x squared, and it is a quadratic, so I'll put that there. The next thing I normally do is reflect in the x-axis, but there's no negative in front, so I'm skipping that step. Our vertex, again, make sure we get it from this thing that we rewrote there. And again, I'm taking the opposite of the negative 2, and that'll give me a 2. So my vertex is at 2, 9. And then we can write our graph. It also has a vertical stretch. You probably wouldn't actually be graphing one of these, but that's at 16. All right, and then we're going over that last example there, C, which I think I'll make that slightly bigger there. And again, the first thing we need to do is factor out that 5 there. We're looking to have no coefficient in front of the x, factoring out the 5. And this time there's no square, so it makes it a little bit easier when we do that first step. And so I'm going to write it as f of x is equal to negative, I'm going to factor out that 5. I'm still left with a negative x there, and I'm dividing those both by 5, and that'll give me a negative 3 left from there. All right, so let's put our steps in. And the first thing is our parent function. There wasn't another like this, but Mr. Stewart went over one of these previously in the notes. Y is equal to absolute value of x. And then our graph is actually going to be looking something like that for absolute value. The second part, the negative is on the outside there. That negative on the outside means reflecting in the x-axis. So I just put it here as a shortcut for that. So that tells me I'm reflecting in the x-axis, which means my graph will then be going down. And my last part, well, not the last part, but our vertex again, we get from the inside value there with the x value first. We always take an opposite of that negative 3, and that leaves us with 3. And then we just take the negative 1 as well. My x value stays within the parentheses or the absolute value there. The negative 1 comes from the other part over there. The last part would be noticing that we do have that negative in front of the 5 there. That's associated with the x. Actually, it's probably better to see it on that spot right there, which means we are going to be reflecting in the x-axis. And again, on that front side, I have the steps there if you want to refer back to that. And so we put in our deal here. We have negative x. And if we're going to put that new vertex there, because we did reflect in the y-axis, I'm going to put that vertex in. And really, since it's a negative x right there, we got the negative. We're going to take the 3 and make that negative. And that'll be our final vertex when we put it together. So that's negative 3, comma, negative 1. And that's a couple of those examples. If you have more questions to this, that's why we have office hours. You would ask either Mr. Whited or Mr. Stewart or myself for clarification on that. But that's some good examples of what you have from those. So again, that's the back side there. Switch that back over to the front side, and that'll be it for now.